Bismillahirrahmanirrahim. Students, welcome to our virtual session of week 13. If you can hear me properly, please raise your hands. Okay. Thank you. Okay, students, we were talking about data storage design in our face-to-face class. We talked about how when you have developed your systems, how you should store your data. I'll give you an overview of the content we have studied in class, and then you can ask me questions if you have any about it. Okay, so we were talking about data storage design. I told you that why we need to design data storage is because of two purposes. Number one, we want to retrieve data efficiently whenever it is needed, and we want to provide the access to information that the user requires. So for these purposes, we design our data storage properly. Then I told you about the formats of data storage. We can store data in the form of files, we can store data in the form of database, and we do have a database management system, which is a software which creates and manipulates the database. This is an example of appointment file, such type of files we create in our system to store the data about like for example, this is for patient appointments system. And sometimes we keep data in the form of a database, in the form of tables. Like here you can see that the appointment file is now broken down into 3 tables. One table is linked to the other tables. Then I told you about the file attributes which are kept in files. According to usage, the types of file: master file, lookup file, transaction files, audit files, and history files. Then these are the types of databases: hierarchical database and network database, relational database, which we have already studied in databases, then object database, and multi-dimensional database. So this is how hierarchical database looked like, where the parent has some children, and the children may have further sub-children. So the database is looking like this, like you are keeping data in the form of a hierarchy. And you can have a database arranged in the form of a network. As you can see here, that the customers are placing orders which are linked to each other. You can have database in the form of relational database, where you maintain primary key and foreign keys to identify and link each table. And you have a structured query language for accessing of data. Another type of database is object database, which is built around objects, and each object contains certain attributes and certain functions. Objects are self-contained. You make object classes which identify the major object categories, and the database management systems which use object database are called object-oriented database management systems. And you can have object and relational features combined in a database management system, which is called hybrid object-oriented database management system. So this is the example we saw. Mostly use multi-dimensional database concepts when you have to store a large amount of data and you want a quick access to that data. So this is an example of multi-dimensional database. Then when you have to make a choice from different databases, that which database is appropriate for your system, then this is a table which is summarizing the pros and cons, advantages, disadvantages, and the usage, data formats about each one of these type of databases. For example, if we talk about relational database, it is leader in the database market, can handle diverse data needs. The major weaknesses: cannot handle complex data. Data types supported are simple, like the basic data types are supported. Transaction processing and decision making, these are supported by this, and then existing data formats are organization dependent. Whatever the organization is following, it adapts to it, and it has good future prospect as well. So relational database is quite suitable one. Whenever you have to make a selection of storage format, it depends on the types of application system and the existing storage format the organization or system is using. I told you that you can move from logical to physical design if you convert your logical entity relationship diagram into physical entity relationship diagrams. You change entities to tables, you change attributes to fields, you add primary keys, foreign keys, and then you add system-related components. So this is an example of a physical entity relationship diagram where each entity attributes are now named according to implementation. Now we know that what is the name of each attribute, which we'll be calling an implementation, and what is its data type. And the rest of the table remains the same, representing one-to-one, one-to-many, or zero-to-many, and cardinality and modality. Now this is a crude matrix for take request process, which is mentioning that which attributes, like this is including the table as well, and these are the attributes contained in that table. So which process is referencing these data items. For optimization, sometimes we for storage efficiency, for data storage efficiency, we sometimes optimize the data model, and so that we can access data more quickly. So sometimes to optimize or to speed up access to data, we sometimes perform denormalization, sometimes we perform clustering for this, and sometimes we have indexing. So the basic purpose is to minimize the access time to database or the data items. This is what I told you about denormalized data model. So you sometimes keep data in both the tables by denormalizing it so that it can be accessed quickly. Clustering is a technique which reduces the number of times data storage must be accessed by physically placing like records close together. Because we want access to physical storage takes time, and it is considered a heavier operation than accessing data from memory. So what we do is that we start placing the related or linked records together in database, so that whenever you have to access another record which is related or linked to the previous one, this can be done quickly. So how we do it? We sometimes perform intra-file clustering and sometimes intra-file clustering. So intra-file clustering means similar records in a table that are stored together, and intra-file clustering means combined records from more than one table that are typically retrieved together. So we do it in this way. We can perform indexing, which is index is a mini table that contains values from one or more fields in a table and the location of the values within the table, just like the index of a book. It's like within a database, you maintain an index from where you can go directly to the detailed information of that. These were some guidelines for creating index. When we have to estimate storage size, you first of all calculate the sum of the average width of all fields in the table. Then you include overhead requirements as well. Then you estimate initial number of records and the growth rate of records as well. And then you calculate the volumetrics. So what will be the volume of each of the table? So every table you calculate a volume, like initial table size, initial table volume. So this is the size, this is the amount it will be taking, and this is the overhead. Like you see here, you can include overhead as well, and total record size is this one. So the total volume in 3 years. So you calculate the total volume in 3 years. If the growth rate is 1000 per records per month, then the total volume in 3 years will be this one. So this tells you that how much storage do you need in 3 years. Files are electronic list of data, generally of 5 types: master, lookup, transaction, audit, and history. Database is a collection of groupings of information, and a DBMS is software that creates and manipulates these. There are a number of methods to optimize data access speed and efficiency. Like clustering, indexing, denormalization. So you can use any of these to optimize the data storage. So these are all the contents we had. So I just now want to know that if you have read the articles. So first tell me, do you have any question from these contents? Do you have any question from the lecture? Okay. Fatma just said no, thank you. Okay. Yes, we do calculate storage. Like we first check that what is the estimated storage, average storage required for each of the record in the table, and then we estimate the maximum number of records in each table. Then we calculate the growth rate of each table. You may be, like, for example, you may be asked to you may be given a table containing details about everything, and you may be asked to tell that what can possibly be its growth rate. It's not difficult at all. See here, now order number is of 8 characters, date is of 7 characters. So if you sum up, you get total 49 characters, and you are saying that overhead is 49%. So 30%. So 30% of 49, you'll calculate 30% of 49, add it up with 49, it becomes 63.7. So the total record size is 63.7. And if initial table size is 50,000, then you can calculate initial volume by multiplying this 50,000 with this 63.7. So this will become initial table volume. This is not difficult. You just calculate it and you will see it yourself, but it's not difficult at all. In exam, you may be given this table, or you may be asked for some information like this is the growth rate and what is the total size. So see, for practice, I would recommend that you solve the practice exercises for this week and see what type of questions they have over there. So okay, you are welcome. Any other question? Okay, so the slides are over now. No, if you don't have any question from lecture, just tell me, have you read the articles I told you to read about 8 reasons of using cloud and why cloud? The 2 articles I mentioned in my class that you have to read. Have you read those articles? Any question from those articles? Okay. Okay, if you have not read so far, just let me know if you have any questions, either through email or in our next virtual class. Okay, inshallah. Okay, I'm available over here since 6 p.m. before a database class. So if you find any question meanwhile from this lecture or from any of the previous lectures or from the article, you can just type in the text panel and I'll reply you over here. Thank you very much.